Okay, kiddos, today we're going to work on solving systems by graphing them. You have actually done this before. It should sound familiar. Have done before is graph a system of linear equations, where you graph two straight lines. You can pretend that one's straight. And you find the solution to the system by naming what they share, whether it's that one point or if they don't cross or if they're totally on top of each other. But today we're going to do systems that involve quadratics. So in your vocabulary section, I think it would be smart, please go ahead and make sure you write this down, because that's what I was just trying to say. You will have one quadratic equation and one linear equation, which means it would be something like a parabola shape and a straight line. So please copy each of these 6 pictures. You can put them together in a chart like this if you'd like. Circles are also quadratics. We won't do any circles today, but we will do those later this year, and it's the same idea. They might cross twice, they might cross once, they might not cross at all. So those are your solutions. 2 solutions, 1 solution, or no solutions. Okay, so let's jump in and do one. To solve them by graphing, you simply graph the straight line equation and you graph the quadratic equation. So let's graph the straight line first, because that would be pretty easy. If you need to write it out in full mx plus b form, just to make sure you're seeing everything, this one begins at 0, the b is 0, and the moves for the slope is up 3, right 1, 1, 2, 1, 2, 3, right 1. 1, 2, 3, right 1. Do it a couple times. You can even go backwards, down 3, left 1, and draw your straight line. I'm sure mine won't come out very nice. That's why you want your points on there, because the points will help you see where things cross. All right, let's work on the quadratic. Our equation is y equals x squared plus 4x minus 2. Try to look and see if it factors. That might be helpful, but otherwise you're on your own. This guy does not factor, so let's just quickly do some of the by hand work. When you have your graphing calculator, you can certainly use that. So I'm going to start by finding the axis of symmetry, which is -2. That's also the beginning of my vertex. The vertex will be -2, comma, something, so we need to plug in a -2 into the equation, right here, here, and work it out with your calculator or in your head with the correct order of operations, and you'll have what you need there. So that'll be a -2 squared plus 4 times -2 minus 2. Do that carefully in your calculator or by hand. You should get a y is -6. So when we plugged in -2, we got out -6. That's our vertex. So I'm going to go to -2, -6, 1, 2, 3, 4, 5, 6. Oh, we got lucky. That probably is a point of intersection, since it happens to be from the same line we graphed in red. All right, let's do some other things to find a couple other points. You can do an XY table, either from your calculator or by plugging in by hand, but I think I would like to just do something simple. The y-intercept is sitting right there, the C position, so 0, -2 is on my graph. And if I think symmetrically, if I move 2 units to the right and landed on -2 from the vertex, then I can move 2 units to the left and also have a point on -2. Let me go back to blue. So that's enough to get the graph of the parabola. Now obviously we're sketching by hand, so you may be very wobbly like I am there with my pen, but the idea is now look at it and tell where they cross. This one, even though I missed my point in both blue and red, is one point that they share, this point right here. So let's write that down. That is the point -2, -6. And another point that they share appears to be, and I actually hit that one, right up here, and that would be the point 1, 3. Obviously, a graphing calculator, or being much more neat with a ruler and all, you will be able to name the exact points. So the solution to this system of a quadratic and a linear equation is the point -2, -6, and the point 1, 3. Okay, so let's do another one. They all pretty much come out the same. It's just a matter of getting it graphed and looking to see if it crosses once, twice, or not at all. So let's do our linear equation, our straight line first. It begins at -2 and counts up to right 1, up to right 1, down to left 1 is also smart to do. The more you do, hopefully, ooh, that is a really bad straight line. But try to use a ruler on your paper. Since I don't have paper, it's harder to do. All right, now let's do our quadratic. We can't really factor it easily, so I would not go the x-intercept route. Let's go find the vertex route by starting by finding the axis of symmetry. So the opposite of b over 2 times a should give us -1 for the x value. If x is -1, we have the beginning of our vertex, -1. We'll plug that in and find a y value to go with it. So let's put a -1 in for x. Y equals -1 squared. Please use parentheses right there, or your calculator would give you the wrong answer. 1 minus 2 minus 2. Y equals -3. So we plugged in a -1, we got out a -3. That is our vertex. So let's go graph that. -1, -3, 1, 2, 3. Now it looks like my line touches right there, but that's my bad drawing, because notice the red dot below it. That's where the line actually crosses in that section. Okay, now let's try to find some other points on the quadratic so that we can draw the parabola. And again, if I'm in standard form, the easiest thing to do is go find that y-intercept right there. 0, -2. No work involved at all. 0, -2 is this point. Now those definitely are the same points. And opposite of that, that was on the right-hand side, so on the left-hand side would be -2, -2. That will be enough to help us graph. I'm going to try to draw it carefully, but this is kind of a mess. It's pretty skinny. And you may be going, how do you know it doesn't cross over there again? This is where a graphing calculator would definitely help you more. But now, I happen to know that the graph is skinnier like that, so the red and the blue graphs only cross in one spot. Right here is the only intersection point. So to solve this system, you would name that point. So they only have one point in common. So the solution to the system is the point 0, -2. Okay, that's it. They're almost all alike, but remember they can cross twice, once, or not at all. Graphing calculators definitely come in handy, so use an app if you're at home with no calculator, or please use your calculators in class. And make sure you're coming to get help.